Well, hello there. This is me here, Sister Senior, and you can call me Sister Gasmer too. And I'm currently taking part in this Google Science Fair 2016, and this is my video about my project and some personal details about my life. And so my project name is Xbot, which is a autonomous robot which is fully programmed by Arduino, Arduino IDE, some kind of C language which we use to program a robot. So I've used Arduino for programming these all my robot, my quadcopter, and my quadcopter has many sensors, gyro sensors, ultrasonic sensors, and some motors, ESCs, brushless motors, and some propellers, and some this kind of Arduino main part is Arduino Mega board. I've used Arduino Mega instead of Uno because it gave me a lot of pins and a lot of some kind of memory, more memory than this Arduino Uno, and higher processing speed than Arduino Uno. So I've used Arduino Mega for adding more stuff in the future, or for further processing. And my country name is Nepal, and I live in Rupande, inside this luminous zone. I live in luminous zone at Rupande, and I live here in Buttle City. You can search it in Google. You'll find Buttle City, and it's BUTWAL, Buttle City. So I live here, and in my family there are 4 members: me, my sister, my father, and my mother. So we are 4 families, 4 members here in family, and I go to school called New Horizon. My school name is New Horizon English Boarding Higher Secondary School. You can call it this New Horizon Institute. So I've just passed my 10th examination, and now I'm going to high school. I was in high school first, but after the 10th class, or SLC, we go to another college, or we go for high study for we call it high school, or +2, like there in our country we call it like that. So I made my quadcopter in the gap of this admission of this +2 and this SLC. So in the gap of that time, I made this quadcopter, and now it's time about my video of this quadcopter. You must be watching that. So bye bye. Well, hello there. This is me here, Sister Gasmer, and I'm going to show you my new quadcopter here. You can see here I made it myself, and I'm going to show you my remote, which I also made it myself by using some kind of Arduino Pro Mini chips, microcontrollers, and some wireless transceiver, and some this analog joysticks, and some programming USB to C or TTL converter, some kind of programmer, right? And a power battery pack. So what I've done is I really played with a Arduino background, because I'm only using all this microcontrolling programming is Arduino, which is really based on C programming, and it was very hard to find out what kind of C programming is. It's really hard to change the programming concept from basics to C programming. It was really hard. So firstly, I want to explain this my remote. So first of all, I'm going to show you, this is my Arduino Pro Mini, which is a microcontroller. Microcontroller given by Arduino. You can buy on the market. You can find it on the market. I think it's not available in this country. You must go to, I think, India or Delhi, somewhere there. So you can find there. And it's a wireless transceiver here. It's the wireless transceiver here, and it's the Arduino Pro Mini, and I've connected this wireless transceiver to this Arduino Pro Mini so we can communicate that all data and signals over this Arduino Pro Mini, and can manipulate that all signals from Arduino Pro Mini to that transceiver. And it's an NRF24L01 transceiver, which is a high China copy. It's not actually that real original transceiver, but it's just a high China copy. And I've used here a battery pack, and one I've used is a USB to serial TTL converter. You know, why I've used it is Arduino Pro Mini don't have a kind of some serial converter, so I couldn't directly connect that Arduino Pro Mini to this computer. And what I've done is I've connected one this USB to serial TTL converter, which converts this all, which connects this USB to serial. So I can program this Arduino Pro Mini so easily, and it's so efficient and it's so good. So all about this, and these are these analog joysticks. Actually, these analog joysticks are really registers, tunable registers, and we don't call it tunable resistor. We call it potentiometers, and like a freaky name, but their name is potentiometers. And these give values to Arduino Pro Mini in analog form, and it really manipulates that value and transfers that values from this wireless transceiver to this Arduino quadcopter. And now the next part of this video is an Arduino quadcopter. So I'm gonna. Hello there, this is me here, Cesar, and today I'm gonna show you my quadcopter explanation. It's explanation about its parts and some other its functions. So let's go on. Okay, let's start. So you can see here my quadcopter, and I've used these all the studs over here for get better performance for stopping vibration given from this quadcopter motors. And what I've done is I've used it for ESCs for motors, Brussels motor, and I've used these all sensors here. You can see here eye-shaped, some kind of two eye-shaped, some headers here, some eye-shaped sensors are here. So this right over here, you can see this is an ultrasonic sensor which measures the distance, how much far is an obstacle is. So first of all, I'm gonna describe about this Arduino board, which is Arduino Mega, and it's a Arduino Mega having 54 digital I/O pin, which gave me better performance than Arduino Uno, and it has higher processing speed, and it has higher this memory. So it's quite efficient than this Arduino Uno. So I use this board for this compiling all of these sensors, echo and trigger pins here, so it can give me a lot more pins than this Arduino Uno. So I use this, and what I used here is a gyro sensor. And actually, a gyro sensor is a sensor which senses its position according to gravity. Means it's it has three axes. Three-dimensional gyros have three axes called X, Y, and Z axis, which is also called roll, pitch, and yaw. So that's the way this quadcopter balances. So I didn't use any flight control board here. I used only two chip, this gyro and this Arduino Mega for flying this robot. And I've used here these sensors here for sensing all the obstacles like walls, or some persons are disturbing this robot, then this robot could escape automatically. So I've created those algorithms right there. And what I've done is I programmed here PID controller algorithms, so my quadcopter will not compensate a lot, and my quadcopter will balance itself by overcoming some kind of errors given by this quadcopter. So this is my whole structure, and I'm gonna tell you about this sensors right here. And so I'm gonna put this throttle up so it works. And sorry about this, this ESC is not functioning well, so it's not starting as other do. So this is my Okay, now I'm gonna start my sensor on here. Okay, now let's see here. If I if I bring my hand near here, then the speed increases. So in this way, it will increase the speed. And if I bring this both together, then if if two objects are here, and then they are coming closer, then it wouldn't actually rotate this too, because it will go upward and there won't be any kind of change. So I've created an algorithm that if these two obstacles are coming from two direction and same axis, then another axis more will be spin, and it will go this way, so it will escape like that. So that's the algorithm of this sensor. And so I'm gonna show you about this two-dimensional servo here. So it's over here. Sorry about that. My PID calculations are going here, and I've multiplied with this angles of the gyros, so it's rotating. Okay, unnecessarily. So this is my here two-dimensional servo. Actually, what I've done is I just put together one-dimensional servo. Means one servo I put in another and attached in another. So I made that, and I made that two-dimensional. So I can show you how it's two-dimensional. So let's turn on this servo. So let's move it. Okay. So what I have to do is okay. So now let's start it again. Let's wait for a minute. So it's on. Okay, you can see here my servo will work. Okay, that's my servo. Okay, this is one dimension, and then this is another dimension. You can see here. Okay, this is one dimension, and this is another dimension. So like that, and here's my laser sensor. Laser pointer is there, and actually that laser pointer is not working because this wire is somehow taken off from this sensor. Okay, now it will work fine now. Okay, now you will see the laser on this ground. Okay, I'm gonna turn it to the ground side. Okay, now it's on. Okay, now let's put it on the ground side. Okay, now you can see here laser coming up, and if I give more ampere or more current, then the laser will burn that object, and we can keep instead of keeping here instead of laser, then we can keep this laser. This laser. We can. It's not necessary to keep here laser. We can keep digital cameras or whatever we want, whatever we are targeting at. Okay, it's purpose-wise. It's not that mandatory to keep here laser. So that's about my robot. My laser diodes are here, and it's a fully compiled, programmed robot, and we can also code it again because this is made of Arduino board, which is really programmable, user-friendly programmable board. So that's about my quadcopter, and you can see here how it flies. Okay, you can also see here how it goes to flight. Okay, so are you ready for the flight? So let's see. So that's about a rough flight. So why I'm not flying it upward than that, because it's indoor flying, so it may be risky. So I got my one rotor damaged by flying indoors. So I'm gonna fly it outside and watching my video. Okay. So that's all for this video. So goodbye. So hello there, this is me here, Sister Sienna, and today I'm gonna show you this program of this quadcopter, which I've made in computer by using an Arduino IDE. So Arduino IDE is mainly C-based program, means it's totally I mean not totally, quite, it's C language. It's, you know, it's like C language. So I've used this all code, programmed this all code for my Arduino quadcopter here, an Arduino robot. So, and you can see here I made it this. Let's go to bottom. So it's 597 lines over there. So this is a too long program. So I've used an Arduino Mega for programming the quadcopter, so I could add more sensors and more items, and I could really attach more stuffs in this quadcopter. So that's my program about this quadcopter, and you can see here I've used many library files, many variables, and many values, and so on. And I've used here 4 setup: gyro setup, gyro calculation or gyro initialization, okay, and this Wi-Fi setup, and server setup, and ESC setup for setting up those all different, means controlling those all devices. Okay, so and I've used also sensor, but there's no setup for a sensor because this new ping.h library file and gave me all setup for this sensor. So that's all about this Arduino quadcopter program. And here's my remote, Arduino remote, and it's a Arduino Pro Mini. You can see here, and I fixed here a wireless transceiver here, and these all are potentiometers and a USB TTL converter. It's USB to serial TTL converter here. And that's a simple remote which I programmed by using this computer only. And you can see here my program of my remote, and you can see here my remote program. Okay, first of all, Wi-Fi setup and stick setup means I didn't have any kind of button. Oops, sorry, my camera battery went off, so I'm gonna start it again. So this is I was here, this Wi-Fi setup, stick setup, and I didn't got any buttons over my remote, so I didn't add more this button setup or some kind of switch setup there. Only I did is I only programmed this all potentiometers or stick setup. So let's count how many lines it is, and you can see here it's nearly 128 line. At the top, at the bottom, I've kept this cursor. It's 128 line, so that's quite better, and it was not more, it was a lot easier to program this remote than this quadcopter. So let's minimize this, and so let's check it out, the serial monitor output here. Okay, where's my serial monitor? Okay, here it comes, and you can see here my throttle, the throttle stick. The throttle stick is 0, the laser is 0. So this is my remote, and you can see here my Arduino Pro Mini and my wireless transceiver here, and these are all my potentiometers and USB stick. And now I'm gonna pull this throttle high, and you can see gradually the value increases here. Okay, you can see here. Okay, gradually the value increases. At the time, my quadcopter is not flying because I've not connected my quadcopter to the battery, so it's not flying. And you can see here the laser value, because this button, this means this potentiometer goes my laser value high. And you may be thinking that what this stuff is. Okay, that is this sensor output. When I make the throttle, this laser higher than this laser value higher than 15, then my sensor starts. Means my sensor all loop and sensor process starts. So let's calibrate it once again, okay, for clear data. Okay, now here we go. Here's my counter here, a counter how many times the program loops, and here's the PID pitch control, PID roll control, angle of the roll, and angle of the pitch, and 4 values given to the quadcopter motors in microseconds especially. And so let's get started with this. This is my motor values. These are my motor values here, and you can see here there are a little difference because my quadcopter is tilted a little bit, and you can see here pitch angle, roll angle. You can see here PID pitch, PID roll. It's been somehow messy because I'm doing auto scroll here. Let's turn this auto scroll down. So now you can see here the clear value of the time. Okay, now you can see here the roll angle, pitch angle. Okay, PID pitch. Okay, let's see top one, 0.13, 0.04, and here 0.13, 0.04, like that. It's the PID pitch value, PID roll value here, and that's all about this. And you can see here the counter. What I've done in the counter is I just kept here the values. So that's about the counter value, and these are, so this is my serial output of the in computer, and we can do anything here. We can write a serial algorithm for for doing set of tasks. For doing set of tasks, we can write algorithm for this quadcopter. It's not handy. You can make your own program. So like this, my quadcopter is ready now. So this is the end of the video. I'm here with this quadcopter. Now it's my first flight outside outdoors, and I'm gonna show you my quadcopter flight. So let's get started. Okay. Sure. Really a rough flight. So let's calibrate it once again.
Oh, good. Well,
hello there, this is me here, Sister Gatsmere, and today I'm going to show you my new quadcopter here. You can see here, right here. And this is my remote, which I made myself with Arduino Pro Mini and this wireless transceiver of 2.4 gigahertz. And this is all a simple kind of remote. And here's my simple quadcopter. It's not really a quadcopter, it's a robot. It has many sensors, and it can do a lot of jobs. It can lift some kind of items to one place to another. And there are many advantages of this, quadcopter. And you can see my sensors are here, and these servos are here for controlling this laser diode, and so on. Now I'm gonna fly this off. Okay, this outdoor flying really is not bad at all. Okay. So back. That was horrible, but sorry to say that. I'm gonna fly it again.
I can't do it.